Let's keep these changes for our stress reduction. And now let's look at the displacement of the mount. Let's switch to displacement in millimeters. Let's open the default max displacement monitor as well. We can see that the forward end of the mount experiences the largest deflection. Let's look at a few design changes aimed at reducing this deflection. We can first thicken the walls running along the length of the mount. We can select the two sides of the most forward wall. We can then use the power select tool and select all coincident faces to select all remaining wall faces. Now, let's pull these faces out by 3 millimeters. The results will start to auto-update, and once complete, the second design point will appear in the monitor. We can see the displacement has improved. And let's save a scene as displace, thicken multiple walls. So now we can test out another idea. We can decrease the transition rate of the sidewalls at the forward end. To do so, let's select these end faces and let's move the coordinate system to an upper edge of one of the faces. Now we can rotate about this axis with the rotation arrows. Select the arrow rotating about the global y-axis and rotate by 10 degrees. We can now increase the height of this front wall. Activate the pull tool and click on the upper face. And also double click on the surrounding edges to keep the shape of the rectangle. Pull by 40 millimeters. And let's save a scene as displace forward transition. Throughout this, we can see all the different variations on the displacement monitor and evaluate the effectiveness of the changes. Let's make one last change aimed at reducing the displacement, but we'll add a bit of automation here. We'll do this by using a parameterization approach. To do so, we'll select the measurement that can be varied and is tied to a geometric change. As an example, we can thicken this wall in the aft direction. However, we will need to ensure that it is not too close to the hole. Click on the hole to view its size. In the lower right-hand side of the window, we can see that it has a 50 millimeter radius. Alternatively, you can go to the Measure tab and measure it from there. Let's begin the process now. To start, enable the pull tool and select the two aft faces on the wall. Now, click on the ruler button on the HUD and select the hole as a reference point. We can now measure the distance between the wall and the circle. Now, click on Add as Parameter next to the measurement. Notice that now you have access to the Parameters Study options. Here you can manage your parameters and perform variation studies. This can also be accessed through the ribbon in the Study group of the Simulation tab. You can open it and see the parameters you added. You can view all parameters created in the Parameters tab. Let's rename the parameter we created to Distance 1. In the Test Cases tab, you can manage test cases from the parameterized physics conditions. Let's add some test cases here. To do so, navigate towards the physics tree and hover over the acceleration and the force conditions. You can directly add a parameter from the physics tree. Alternatively, you can double-click on the physics condition and add a parameter from the options in the HUD. Let's add them from the physics tree. We can now add a test case by clicking Add a Case, or we can generate a range of test cases. For this example, let's just create 2 test cases, with the second test case being a forward acceleration load. Let's rename them accordingly. Now, on the Variations tab, you will be able to create various design variations based on both the geometric parameters and the load cases created. Similar to the previous tab, you can create individual variations or a range. This time, let's create a range. To do so, click here, and we'll be prompted with inputs to create our range of variations. First, let's select the geometric parameter. Next, let's assign the range. Recall that our starting distance is the original distance, and we must not get too close to the 50 millimeter hole. Therefore, if we want to keep a clearance of 5 millimeters, our end value should be 55 millimeters. Now, we can enter the interval or number of variations we want. Let's create 4 variations for this case. Now, we'll just choose the test cases to include. In this case, we'll combine with all test cases. We can now create the variations. From here, we can switch to different variations on our 3D body by selecting individual variations and clicking the Set as Current button. Note that if the solver is running, the solution will begin to update. To navigate through various variations without solving, simply pause the solver. Now, you can either update the solutions of individual variations, or you can update solutions of all created variations through the Update options. Let's update all and speed up to all the variations solved. Okay, we can now see all of our results. Before sorting through the results, let's capture the final design variation, and let's save a scene as Final Parameter Study. Note that only results for monitors are reported. We can see different solutions in the monitors, which will be stacked in one design step. You can see which variation each point belongs to by hovering over it. We can also view these results from the Variations chart, which can be accessed through the Variations tab in the Parameter Study pop-up. Let's click on the Show Variations Chart button. We can now see the variations with our choice of axes. You can hover over variation points to show additional details. We can see both on the Variations chart and on the monitor that increasing the thickness of this wall reduces the displacement. Let's close all windows and continue our case study.